This lesson will focus on solving equations quadratic in form. An equation quadratic in form is an equation that can be written as a quadratic equation after a substitution is made. That is, the equation is of the form a times some expression squared plus b times some expression plus c equals 0. The key is that the expression in parentheses must be the same. We often replace this expression with a variable u and call this process u substitution. Let me give you examples of what this substitution step looks like. If I have the equation x squared minus 3x squared minus 10 equals 0, what I want to do is see if there's a connection between the variable expressions in the first and second terms. I notice that I can write this as something squared minus 3 times something minus 10 equals 0. Well, the variable expression in the middle term has to be my something. That is, if I put that x squared in parentheses, notice that if I substitute it in the first, x squared squared is x to the fourth. So what I can do then is call u the quantity x squared, and then I can rewrite this equation as u squared minus 3u minus 10 equals 0. So after a substitution was made, the equation is quadratic. We'll actually go through and solve them in just a moment, but I just want you to see this process of rewriting the equation as a quadratic after a substitution is made. The second example, 4 times y minus 1 quantity squared plus 7 times y minus 1 plus 3 equals 0. Well, it is already in the form of 4 times something squared plus 7 times something plus 3 equals 0. That something is y minus 1. So in this case, if we replace y minus 1 with u, our equation becomes a quadratic for u squared plus 7u plus 3 equals 0. Our last example here is 2w to the 2/3 minus 3w to the 1/3 minus 20 equals 0. So we want to see if we can write it in the form of 2 times something squared minus 3 times something minus 20 equals 0. Again, that something has to be what's in the middle term, which is w to the 1/3. Well, when I put w to the 1/3 in the first parentheses, is w to the 1/3 squared w to the 2/3? Well, it is. If you remember, when you raise a power to an exponent, you multiply the exponents to get 1/3 times 2, or 2/3. So I can rewrite this with u being w to the 1/3 as 2u squared minus 3u minus 20 equals 0. So you know that these are quadratic in form when there is a relationship between the variable expression in the first term and the second term, in such that the first one is the square of whatever the variable expression is in the middle term. So let's solve x to the 4th minus 3x squared minus 4 equals 0 using the u substitution. So we just talked about that x to the 4th is really x squared squared minus 3 times x squared minus 4 equals 0. So letting u equal x squared, we're going to get u squared minus 3u minus 4 equals 0. This is a quadratic equation that we solve by factoring. U squared is u times u. The factors of 4, whose difference is 3, are 4 and 1. Different signs, with the larger one being negative. So we have u minus 4 times u plus 1 equals 0. Setting these factors equal to 0, so we get u is equal to 4, or u is equal to negative 1. But we can't stop there. This equation was in terms of x. Our solutions are only in terms of u. So once we get u, we need to replace the u with x squared. So x squared is equal to 4, or x squared is equal to negative 1, giving us x equals plus or minus the square root of 4, which is 2, or plus or minus the square root of negative 1, which is plus or minus I. Solving x to the 2/3 minus 3x to the 1/3 minus 4 equals 0. We think about, can we write this as something squared minus 3 times something minus 4 equals 0. And our something is x to the 1/3. And it does turn out that x to the 1/3 squared is x to the 2/3. So we replace x to the 1/3 with our variable u. And that gives us u squared minus 3u minus 4 equals 0. Factoring gives us u and u, the factors of 4 whose difference is 3, 4 and 1, different signs with the larger one being negative. So we get u minus 4 equals 0, or u plus 1 equals 0. So u equals 4, or u equals negative 1. So now, again, we don't want our solutions in terms of u, but in terms of x. We replace u with x to the 1/3 is equal to 4, or x to the 1/3 equals negative 1. Now with equations with rational exponents, we have to raise each side to the exponent of 3, because 1/3 times 3 gives us 1. So x to the 1/3 cubed is just x. 4 cubed is 64. And our second solution is x equals negative 1 cubed, or just negative 1. Okay. For our third example, we have 2x to the negative 2 minus 7x to the negative 1 plus 6 equals 0. Remember that a negative exponent, x to the negative 2 just means 1 divided by x squared. X to the negative 1 is 1 over x. In general, x to the negative n is 1 divided by x to the n. So we could write this equation as 2 times 1 over x squared minus 7 times 1 over x plus 6 equals 0. So here again we're trying to think about, can we write that as 2 times something squared minus 7 times something plus 6 equals 0? Well, our something is 1 divided by x. Because do you agree that 1 divided by x squared is exactly 1 divided by x squared? So in this case, we let u be 1 divided by x. Our equation, after making the substitution, is 2u squared minus 7u plus 6 equals 0. Now we factor. 2u squared is 2u times u. The factors of 6 are either 1 and 6 or 2 and 3, but the only way that we can get a 7 is to put 3 with the 2u and 2 with the u, because the outer is 4u, the inner is 3u. We know they have to be the same sign and they're both negative. So we get that 2u minus 3 is equal to 0, or u minus 2 is equal to 0. So 2u equals 3. So u is 3/2. Or u is equal to 2. But again, I can't stop there, right? I'm not looking for u, I'm looking for x. X is, or u is 1 divided by x. So 1 divided by x is 3/2, or 1 divided by x is 2. So to solve that equation, I can cross multiply to get 3x equals 2. So x is 2/3. Or here, 2x equals 1. So x is 1/2. So my solutions are 1/2 and 2/3. Another example, I have 1 minus 3 divided by x, quantity squared, minus 7 times 1 minus 3 over x, plus 10 equals 0. So I'm again thinking, can I write this as something squared minus 7 times something plus 10 equals 0? Well, it was really already in that form, right? That something is 1 minus 3 divided by x. So we want to let u equal the 1 minus 3 divided by x. Replacing the 1 minus 3 over x with u gives us u squared minus 7u plus 10 equals 0. We now factor the factors of 10, whose sum is 7, or 5 and 2. They are the same sign because of our sum on the last term, and they're both negative. So we have u minus 5 equals 0, or u minus 2 equals 0. So u is equal to 5, or u is equal to 2. But what am I going to say? We're not done there. We need to get this in terms of x. So we set 1 minus 3 over x equal to 5, or 1 minus 3 divided by x is equal to 2. So we subtract 1 from each side to get negative 3 divided by x equals 4, or negative 3 divided by x equals 1. Cross multiplying gives us 4x equals negative 3, or x is negative 3/4. And then x equals negative 3. So again, quadratic in form, you need to see some connection between the variable expression in the first term and second term, such that the first term is the second term's expression squared. If you see that, call that expression u, turn the equation into a quadratic, solve that quadratic equation, but then don't forget to substitute to find out the original variable's value, not just u's value. Happy solving!